Alrighty, so we're going to simplify some exponents. We're going to do some multiplication and division rules. So if you're going to talk about exponents, the first thing you need to understand is that x cubed means x times x times x. Exponents are shorthand multiplication. 3x is different. That means x plus x plus x. Multiplication is fast addition. Exponents are fast multiplication. So when you see 2 times 2 times 2 times 2, that is 2 to the, how many of them are there? 4. When you see 3 times 3 times 3 times 3 times 3 times 3, there are 6 3s. And you can figure out what 3 to the 6 is with your calculator, but that's not the most important thing right now. Now when you got a couple x's, you have a 5, doesn't have any friends, you got a couple x's and a y. Now if it helps you, you can put this in different order, so I'll put the coefficients out front. Then I'll put my x's, and then I'll pair my y's. You're allowed to move things around because multiplication is commutative. That means you can change the order. That helps me because now I can be like, oh, 3 times 4, that's 12. X times x, that's x squared. And y times y, that's y squared. And you're done. So if I say, okay, x times x squared is, I'll say xx times x squared is xx. So you start to look at this and say, well, that's 1, 2, 3, 4, 5, that's 6 x's. 1 plus 2 plus 1 plus 2 is 6. Okay. X squared, so xx times xx times xx times xx. 2, 4, 6, 8, that's x to the 8th. Ah, okay. So all these exponents are saying there's a certain amount of x's. There's 2, 2, 2, 2. 2 times 4 is 8. Okay, so we add them up. Let's see, x times x squared times y squared times y to the 4th. So I move these around. X squared, yeah. X squared, yeah. Y squared, yep. Y to the 4th, okay. So how many do I got? I got a total of 1, 2, 3, 4, 5 x's and 6 y's. 5, wait a minute. 1 plus 2 is 5. 2 plus 4 is 6. Instead of writing it out all the time, you can remember that when you multiply exponents with the same base, you add the exponents. When you, let's say you multiply powers with the same base, add the exponents. So your rule is helpful, but you need to know where the rule comes from. Otherwise, exponents start to become a little unwieldy, a little tricky. So let's do a couple problems here. Again, I could figure out what these numbers are, but I'm really mostly concerned about the exponent rules. So if you have 3 11s and 2 more 11s, that means you have 5 11s getting multiplied, 11 to the 5th. If you have 2 5s and 3 5s, that's 5 5s, and then you have 3 cubed. 4r times r cubed, so this will mess people up. 4r times r, 4r to the 4th. There you go. 3 plus 8 plus 13. That's a total of 24. You could write those out, x, and then 8 more, and then 13 more. 13 plus 8 plus 3 is 24. All right, C, how many do I have? 3 plus 6 plus 8, so 9 plus 8, 17. Oops, C to the 17th. 3 and 9 make 12, so D to the 12th. All right, so this next one's kind of tricky. Again, if it helps you, change the order, but what you got to realize is this is multiplication. So I could write this same exact problem like this. 2 to the 4th, m to the 8th. These are all getting multiplied. So if you think of it that way, you can just say, well, okay, I got 2 2s and 4 2s, that's 6 2s, 3 11s and 8 11, or 3 and 8 make 11 m's. Let's see, 5 times 3 times 3, 9 times 5 is 45. X cubed and x squared make x to the 5th, y to the 6th. Okay, now you have a minus sign out front. Think of that as a -1. It doesn't really affect anything. -1 times. Now we have x to the 6 and 4 make 10, y to the 4th. Don't let the minus sign freak you out. You could write it like this if you want, but the minus sign doesn't do anything. If it was inside the parentheses, you might have a different issue, but it's not. And last one, we're just going to, this is kind of like scientific notation. 5 times 3 is 15, and we'll say times 10 to the 7 and 14 make 21 tenths. So that's 21 zeros. That's a lot of zeros. So those are your multiplication rules, and there's some practice. What do you think about 2 to the 4th over 2 squared? 2 to the 4th means 2 times 2 times 2 times 2. 2 squared means 2 times 2. So what happens to the rules? Well, I know that 2 divided by 2 is 1, and 2 divided by 2 is 1. So I end up with 2 squared in the top. So there are 2 2's in the top. I do the same thing here. C times C times C times C over C times C times C. That's what this means. 3 of them would cancel out, and you have 1 in the top. 6 and 8. Well, I think what's going to happen here, I'll write one more out. 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5, 6. The way you want to go about this is you want to say, how many are going to cancel out? Well, if there's 8 on the top and 6 on the bottom, 6 are going to cancel out. 4, 5, 6. 6 of them are going to cancel. I kind of missed that one, which means you will have 2 left, and they are in the top. So you need to decide where they are. That's probably the most important thing. Now, if you start to combine rules, you can do this a couple ways. You could just say, oh, the fourths are going to cancel out, and you get x squared. Or you could start to use the rules that we know and say x to the 4th times x squared is x to the 6th. And then I could cross out 4. 4 are going to cancel out, 2 are left in the top. So you get the same answer either way you think about it. It's usually a good idea to simplify first. So b squared and b to the 7th make b to the 9th, because it's 2 plus 7 is 9. And then we're going to do the same thing with a's. If there are 3 in the top and 2 in the bottom, 2 will cancel out. You will have 1 in the top. So you can write a to the 1st, b to the 9th just stays up there. And if you have to put it over a fraction, over 1, you don't really have to put it over 1, but you can. Either way is fine. So what's the rule here? When you divide powers with the same base, when you divide powers with the same base, you subtract the exponents. However, this rule can be tricky. So what I suggest you do is figure out where your variables are going to be before you think of it in terms of subtraction. Because if you get negatives, it gets really sketchy. You got to be careful. So if I start to think about this, the way I'm going to say it is, how many 2's are going to cancel out? Well, there's 3 in the bottom and 5 in the top. So 3 will cancel out. How many are left? 5 minus 3 is 2. There are 2 2's in the top, so 2 squared. You have 3 3's in the top. You have 1 3 in the bottom. 1 will cancel out. You will have 2 left in the top. You have 13 C's. 12 plus 1 is 13. There's 13 in the top. There's 8 in the bottom. So 8 will cancel out, and you will have 5 left in the top. You have 13 X's in the top. You have 5 in the bottom. 5 of them will cancel out. You will be left with 8 of them in the top. Y to the 6th, Z to the 4th. 2/3 is a fraction. Do not let anything about exponents change that idea. 2/3 is still a fraction. It cannot be reduced, so we're just going to say 2/3 is still 2/3. But when you have 12 C's in the top and you have 3 C's in the bottom, 3 of them would cancel out and you would be left with 9 in the top. And then D just hangs along there. 13 in the top, 8 in the bottom. 8 of them cancel out. You have 5 left in the top. That's basically the same problem as this one. 8 in the top, 3 in the bottom. 3 cancel out. You have 5 left in the top. 8 and 4. So there's 4 going to cancel out. You'll have 4 A's in the top, and then when you multiply, you add, so B to the 10th. When you multiply exponents or powers to the same base, you add the exponents. Keep it moving. This is 12 and 8. So 8 of them will cancel out. You'll have 4 left in the top. And then B times B to the 8th is B to the 9th, also all in the top. That's a total of 13 A's in the top because you got 12 plus 1. So 13 minus 9 is A to the 4th. X to the 4th times x squared is x to the 6th. And now I can say, well, 4 of them will cancel out. You will have 2 left in the top. And I think this is the last one. We have a to the 3rd times a to the 7th, so that's a to the 10th, b squared over a squared. And then you have 2 a's in the bottom that are going to cancel out with 2 a's in the top. You will still have 8 a's in the top, and b squared just kind of comes along for the ride. Again, you can write it over 1 if you want, but if it all cancels out in the denominator, you don't really need to do that. So that's our exponent. First couple rules: multiplication, division. You guys got some Khan Academies you should be working on, so go ahead and get going, and good luck.